Albert Einstein. His life and universe. Early life and education, 1879 to 1900. Albert Einstein was born on March 14, 1879, in Ulm, Germany, to Hermann and Pauline Einstein, a middle-class Jewish couple. His father owned an electrochemical factory, and his mother managed the household. Young Albert was a quiet and contemplative child. Contrary to popular myth, he was not a poor student. In fact, he excelled in mathematics and science from a young age, although he disliked the rigid and rote learning methods prevalent in German schools. He often questioned his teachers and the established scientific dogmas, displaying an independent and critical mind that would characterize his entire life. One of the pivotal moments in his childhood was the gift of a compass at the age of 5. The seemingly invisible force that caused the needle to point north sparked a deep curiosity about the natural world, a curiosity that would drive his scientific inquiries for decades. He also found solace and intellectual stimulation in music, particularly playing the violin, a passion he maintained throughout his life. Einstein's formal education began in a Catholic elementary school in Munich. Later he attended the Luitpold Gymnasium, where he found the strict militaristic environment stifling. His rebellious nature and his preference for independent thought often clashed with the school's authoritarian approach. This led to a sense of alienation and a growing mistrust of authority. He once famously said, "It is in fact nothing short of a miracle that the modern methods of instruction have not yet entirely strangled the holy curiosity of inquiry." In 1894, his family moved to Milan, Italy, due to his father's business struggles. Albert stayed behind in Munich to finish his schooling, but, feeling isolated and unhappy, he eventually dropped out and joined his family. This decision led to a confrontation with his parents, who were concerned about his lack of a clear future. However, this period in Italy further fueled his independent thinking and his contemplation of fundamental questions about the nature of light and space. To pursue his education, Einstein renounced his German citizenship in 1896 and enrolled in the Swiss Federal Polytechnic in Zurich. This institution offered a more liberal and scientifically oriented environment that suited his intellectual curiosity. Although he often skipped lectures and relied on his friend Marcel Grossmann's notes, he excelled in physics and mathematics. It was here that he met Mileva Maric, a fellow physics student from Serbia, who would become his first wife and a significant intellectual companion in his early scientific endeavors. Despite his academic strengths, Einstein struggled to find a teaching position after graduating in 1900. His independent and critical nature may have been perceived as arrogance by some of his professors. For a time he worked as a tutor and took on odd jobs, facing considerable financial insecurity. The Miracle Year and the Special Theory of Relativity, 1902 to 1905. In 1902, Einstein secured a position as an examiner at the Swiss Patent Office in Bern. This seemingly mundane job proved to be surprisingly conducive to his scientific work. The routine nature of his tasks allowed him ample time to ponder profound physics problems. As he famously quipped, the patent office was his secular cloister. The year 1905 is often referred to as Einstein's Annus Mirabilis, Miracle Year, because he published 4 groundbreaking papers in the prestigious journal Annalen der Physik, each of which would revolutionize different areas of physics. 1. On a heuristic viewpoint concerning the production and transformation of light. This paper proposed the concept of light quanta, later named photons, and provided an explanation for the photoelectric effect. Einstein argued that light, while exhibiting wave-like properties, also consists of discrete packets of energy. This idea was revolutionary, as it challenged the prevailing wave theory of light and laid the foundation for quantum theory. It was for this work that Einstein was awarded the Nobel Prize in Physics in 1921. 2. On the movement of small particles suspended in stationary liquids required by the molecular kinetic theory of heat. This paper provided a theoretical explanation for Brownian motion, the random movement of particles in a fluid. By mathematically analyzing this phenomenon, Einstein provided strong evidence for the existence of atoms and molecules, which was still a matter of debate at the time. His work allowed for the determination of the size of atoms and Avogadro's number. 3. On the electrodynamics of moving bodies. This paper introduced the special theory of relativity. It fundamentally changed our understanding of space, time, mass, and energy. The theory is based on 2 postulates. The laws of physics are the same for all observers in uniform motion. The speed of light in a vacuum is the same for all inertial observers, regardless of the motion of the light source. From these seemingly simple postulates, Einstein derived remarkable consequences, including time dilation, time passing differently for observers in relative motion, length contraction, objects appearing shorter in the direction of motion, and the relativity of simultaneity. Events that are simultaneous for one observer may not be simultaneous for another in relative motion. 4. Does the inertia of a body depend upon its energy content? This short paper introduced the most famous equation in physics, E equals mc squared. This equation establishes the equivalence of mass and energy, stating that a small amount of mass can be converted into a tremendous amount of energy, and vice versa. This insight had profound implications for nuclear physics and our understanding of the energy sources of stars. These 4 papers, published in a single year by a relatively unknown patent clerk, transformed the landscape of physics and catapulted Einstein into the scientific limelight. His ability to think independently and challenge long-held assumptions led to these revolutionary breakthroughs. The General Theory of Relativity and Growing Recognition, 1906 to 1919. Following his groundbreaking work in 1905, Einstein began to gain recognition within the scientific community. He received his doctorate from the University of Zurich in the same year. He held various academic positions in Switzerland and Germany, including at the University of Bern, the University of Zurich, and finally, as the director of the Kaiser Wilhelm Institute for Physics in Berlin in 1914. During this period, Einstein turned his attention to extending his theory of relativity to include gravity. The special theory dealt with objects moving at constant velocities, but it did not account for acceleration or the force of gravity. For nearly a decade, Einstein grappled with this problem, facing significant intellectual challenges. He realized that gravity was not a force in the Newtonian sense, but rather a curvature of spacetime caused by the presence of mass and energy. In 1915, after years of intense work and collaboration with mathematicians like Marcel Grossmann, Einstein presented his general theory of relativity. This theory described gravity as a geometric property of 4-dimensional spacetime, where massive objects warp the fabric of spacetime, and this curvature dictates how other objects move. The theory provided a more accurate explanation for the orbit of Mercury, which Newtonian gravity could not fully account for, and predicted new phenomena such as the bending of light around massive objects and gravitational redshift, the change in frequency of light in a gravitational field. The predictions of general relativity were spectacularly confirmed during the solar eclipse of 1919, when astronomers observed the bending of starlight as it passed near the Sun, precisely as Einstein had predicted. This observation catapulted Einstein to international superstardom, making him a household name and a symbol of scientific genius. Newspapers around the world hailed his theory as a revolutionary achievement. Personal life and turmoil. Einstein's personal life during this period was complex and often tumultuous. His marriage to Mileva Maric, which had been a close intellectual partnership in the early years, began to deteriorate. They had 3 children: Liesl, whose fate is uncertain, Hans Albert, and Edward. The pressures of Einstein's burgeoning career and their differing personalities led to increasing strain in their relationship. They eventually divorced in 1919. During his marriage to Mileva, Einstein had developed a relationship with his cousin Elsa Lowenthal. They married in 1919, the same year as his divorce. Elsa was a supportive and caring companion, although their intellectual connection was not as deep as with Mileva. Elsa had 2 daughters from a previous marriage, Ilse and Margot, whom Einstein treated as his own. Later years, political activism and the quest for a unified field theory, 1920 to 1955. In the later decades of his life, Einstein continued to make significant contributions to physics, although none matched the revolutionary impact of his earlier work. He became increasingly involved in political and social issues. As a Jew, he was deeply concerned about the rise of Nazism in Germany and the persecution of Jews. In 1933, after Hitler came to power, Einstein renounced his German citizenship and emigrated to the United States, where he accepted a position at the Institute for Advanced Study in Princeton, New Jersey. In the United States, Einstein became a vocal advocate for peace, civil rights, and international cooperation. He was deeply troubled by the development of nuclear weapons and the potential for their catastrophic use. In 1939, fearing that Nazi Germany might develop atomic bombs, he wrote a letter to President Franklin D. Roosevelt urging the United States to initiate its own nuclear research program, which eventually led to the Manhattan Project. However, Einstein himself did not participate in the project and later regretted his role in advocating for it. For the remainder of his life, Einstein dedicated much of his effort to the pursuit of a unified field theory, a single theoretical framework that would unify all the fundamental forces of nature, including gravity and electromagnetism. Despite his relentless efforts, he was ultimately unsuccessful in this quest. The strong and weak nuclear forces were not well understood during his time, and a complete unified theory remains one of the major unsolved problems in physics today. Einstein's later years were marked by both scientific pursuits and a growing sense of isolation from the mainstream of physics, as new developments in quantum mechanics took center stage. While he had played a crucial role in the early development of quantum theory, he remained skeptical of its probabilistic interpretation and famously quipped, "God does not play dice with the universe." Despite his disagreements with some aspects of quantum mechanics, Einstein remained a towering figure in science, revered for his profound insights and his unwavering commitment to understanding the fundamental laws of nature. His work continues to inspire and influence physicists to this day. Death and legacy. Albert Einstein died on April 18, 1955, at the age of 76, in Princeton, New Jersey, due to an aortic aneurysm. In his final moments, he was reportedly working on a speech for a television appearance commemorating the 7th anniversary of Israel's independence. Einstein's legacy extends far beyond his scientific achievements. He became an icon of intellect and curiosity, a symbol of the power of human thought to unravel the mysteries of the universe. His theories of relativity revolutionized our understanding of space, time, gravity, and the cosmos, laying the groundwork for many subsequent advancements in physics and cosmology, including the development of GPS technology, black hole physics, and the study of the early universe. His unwavering commitment to social justice and peace also left a lasting impact, making him a role model for scientists and citizens alike. Einstein's life and work serve as a testament to the transformative power of intellectual curiosity, critical thinking, and a relentless pursuit of knowledge. His name remains synonymous with genius, and his contributions continue to shape our understanding of the universe we inhabit.